Welcome to YouTube channel scientific underscore math. We are discussing a types of matrices with definition, properties and example. In previous lectures, we have already discussed the diagonally dominant matrix and the Hermitian matrix. In this lecture, we will discuss the skew Hermitian matrix and I will provide the link in video description of all these lectures you can watch. Okay, so let's go. Skew Hermitian matrix. A square matrix is said to be skew Hermitian matrix if its conjugate transpose if its conjugate means if its conjugate transpose is equal to the negative matrix itself mean negative matrix itself, then we said the given matrix is the skew Hermitian matrix. Okay, so, for example, we have a square matrix of order n cross n is a skew Hermitian matrix if the conjugate transpose is equal to the negative of the matrix. Okay, so let's discuss example, and we have an example. Find if the given matrix is a skew Hermitian matrix. Okay, so if we suppose let A is equal to this matrix, and we have two steps. First we find the conjugate of the transpose of the matrix and then we find the transpose. Okay, and we know that what we do in conjugate the sign of the imaginary numbers are changed from positive to negative and negative to positive. Here we can see that these are the imaginary numbers, these are so the sign of these numbers, these terms will be changed from positive to negative and negative to positive. Okay, so here we have the conjugate of the matrix A, and now we will find the transpose of the matrix conjugate matrix in step 2. Okay, and we know what we do in transpose, we change the rows into columns. Okay, so this is the first row, so this will become the first column, and here we can see that this is changed into column, and the second row will be changed into second column. Okay, now we will take this negative sign common, and after taking common we can see that this is the matrix A, given matrix. So this means the conjugate transpose of the given matrix is equal to the negative of the matrix. This implies that the given matrix is the skew Hermitian matrix. Okay, now we discuss some properties of the matrix, and here we have some properties of the matrix. The diagonal elements of the skew Hermitian matrix are either purely imaginary or zero. Okay, here we can see that these are the imaginary, or these can be zero. Okay, next the non-diagonal elements of a Hermitian matrix are complex numbers. Here we can see that these are the non-diagonal entries are complex numbers. Okay, third we have a skew Hermitian matrix is diagonalizable. What is diagonalization? In uh, earlier lectures we have already discussed the diagonalization of the matrix. For example, we have a matrix and we diagonalize the matrix. We write the given matrix into the product of the eigenvectors matrix that contain the eigenvectors into the diagonal uh, matrix that contain the eigen values into the inverse of the diagonal into the inverse of the eigenvectors matrix. So I will provide the link of diagonalization of a matrix in video description, you can watch. Okay, so next one we have its eigenvalues are either purely imaginary or zero. In skew Hermitian we have seen the eigenvalues are all real, and in skew Hermitian matrix the eigenvalues can be zero or imaginary, purely imaginary. A skew if A is skew Hermitian, then an is uh, also skew Hermitian. If n is odd and an is Hermitian, if n is even, then the matrix is the skew Hermitian. Okay, the sum or difference of two skew Hermitian matrices is always the skew Hermitian. The scalar multiple of a skew Hermitian matrix is also skew Hermitian, and if A is skew Hermitian, then the inverse of the matrix is also then this inverse of the matrix is the Hermitian matrix. Okay, so thank you so much for watching my video. Please subscribe my channel scientific underscore math for more videos.